So let's start with the third part of the machine learning tutorial. Now here we are going to discuss the decision tree. Now a decision tree is a flowchart like structure in which each internal node represents a test or an attribute. For example, whether a coin flips, when you flip a coin, it comes either head or tail. Each branch represents the outcome of the test, and each of the leaf node represents a class label. Decision taken after computing all attributes. Now a decision tree is a simple representation for classifying example. It's a supervised machine learning where the data is continuously split according to the certain parameter. Decision tree consists of nodes test for the value of certain attribute. Edges, branches correspond to the outcome of a test and connect to the next node or leaf. Leaf nodes are terminal nodes that predict the outcome, represent class labels or class distribution. Now let us try and understand with an example now. As a marketing manager, you want to set of a customer who are most likely to purchase your product. Now how will you decide about that? So you can plan your budget in accordance with that if there is a potential customer, you can allocate more budget. If it is a lesser potential customer, then you may allocate lesser product. So how you can save your marketing budget or allocate your marketing budget accordingly. Fund allocation problem can be handled in this way. Similarly, another example, suppose you are a loan manager in a bank or a financial institution. You need to identify risk loan applications to achieve a lower loan default rate, because there are so many applications which are being submitted for loans, and it is very difficult to segregate that which one is the risk free and which one is the risky application. So this process of classification of customers into a group of potential and non-potential customers or safe or risky customers of loan is known as a classification problem. So classification is a two-step process: learning step and prediction step. In the learning step, the model is developed based on given training data. In the prediction step, the model is used to predict the response from given data. Decision tree is one of the easiest and popular classification algorithm to understand and interpret your results. It can be utilized for both classification and regression kind of a problem. Classification tree, you will have either yes or no as the result. Classification tree is built through a process known as binary recursive partitioning. This is an iterative process of splitting the data into partitions and then splitting it further on each of the branches. Regression trees, which is a continuous data type. So decision trees where the target variable can take continuous values, typically real numbers, are called regression trees. For example, price of a house or a patient's length of stay in a hospital, etc. These are the classic examples where decision trees can be applied. Creation of decision tree. In this method, a set of training example is broken down into a smaller and a smaller subset, where at the same time an associated decision tree get incrementally developed. At the end of the learning process, a decision tree covering the training set is returned. So the key idea is to use a decision tree partition the data space into cluster or dense regions and empty regions. So you can always get that kind of a outcome, and with the help of that you can make your decisions. In the decision tree classification, a new example is classified by submitting it into a series of tests that determine the class labels of that example. These tests are organized in a hierarchical structure called a decision tree, and the decision tree follow divide and conquer algorithm. So let's now talk about the confusion matrix. Now confusion matrix is a very helpful feature available in the decision tree and definitely in the artificial intelligence. It is a confusion matrix, is a tabular summary of the number of correct and incorrect predictions made by the classifier. It can be used to evaluate the performance of a classification model. The confusion matrix is a table that is often used to describe the performance of a classification model or classifier on a set of test data for which the true values are known. So the structure of your confusion matrix is exactly like this, the 4 quadrants that you are seeing, and then on left you are having actual no or actual yes, and predicted no and predicted yes on the top. The confusion matrix itself is relatively simple to understand, although it is known as confusion matrix, but actually it helps remove the confusion. So confusion matrix is used as a performance measurement technique for machine learning classification. It's a kind of table which helps you to know the performance of the classification model on a set of test data. For that, the true value are known. The term confusion matrix itself is very simple. Here, some simple explanation is given for the technique. So you can see, that whatever we have discussed in the previous slide, the same is further explained. That is, on top you have the predicted class, on left you have the actual class, and then against each one of them you have positive and negative, and then below them you have the true positive, then false negative, false negative, and true negative. That's how this can be classified. Now 4 outcomes of the confusion matrix that we can see visualizes the accuracy of a classifier by comparing the actual and predicted classes. The binary confusion matrix is composed of squares, and that is how it can be predicted. Now TP, that is true positive, predicted values correctly predicted as actual positive. FP, false positive, that means predicted values incorrectly predicted as actual positive, although because it is not positive, but it is predicted, that is why it is false positive. The negative values predicted as positive. False negative means positive values predicted as negative. And true negative means predicted values correctly predicted as actual negative. So that is how you can absolutely clear that what is the actual position. Now one can compute the accuracy. Now you can calculate, because whatever result you have received with the help of your model, you can further verify. So accuracy is equal to TP plus TN divided by TP plus TN plus FP plus FN, and you can see the outcome of this should be almost equivalent to that. So let's start with an example confusion matrix for a binary classifier, and with that we will have better clarity. Now here in this case the total number of samples that you have is 165, that is an N, and then predicted no is 50, predicted yes is 100, and actual no is again 50 because that is the coordinates, and actual yes is 5 in first case and second is 100 in second case. Now what can we learn from this matrix that we have seen? There are 2 possible predicted classes, yes and no. If we were predicting the presence of a disease, for example, yes would mean they have the disease and no would mean that they don't have the disease. The classifier made a total of 165 prediction. That is what we have seen. N is equal to 165. So for example, 165 patients were being tested for the presence of that disease. Out of these 165 cases, the classifier predicted yes 110 times and no 55 times. In reality, you will see that 105 patients in this sample have the disease and 60 patients do not have the disease. So that is how you can see, and that is where this confusion matrix is very, very helpful. Let us now define the most basic terms, which are whole numbers. That is, true positive means that there are cases in which we predicted yes, they have the disease, but they do have because it is true positive. So they are predicted as they are having the disease and they do have the disease. True negative means that we predicted no, but they don't have the disease. That means true negative. Then false positive means that we predicted yes, but they don't actually have the disease. That is false positive. Also known as type 1 error. And false negative, that is we predicted no, but they actually do have the disease. Also known as type 2 error. So that is how you can actually distinguish between the two, and that is where the confusion matrix helps in a big way. So this completes our third part of the machine learning, and we will now move on to the fourth part. Thank you.